So welcome to the GP Devs Meetup number 4, I believe. This is Giddy Up with Golang, yeah, with Tyler Arsenault here. And I guess take it away, Tyler.
Yeah. All right. So yeah, this is like Kobe said, Giddy Up with Golang. I'm basically just here to talk about Go and walk you through some simple Go stuff. So we'll get started here. So first off, I'll start with a little bit about me. I am a software engineer. I've been a software engineer for roughly about 3.5 years now, primarily in the web industry. I build backend web applications for a company called Coho. We build microservices all in Go. And yeah, that's pretty much it. So what is Go? So Go is a statically typed language. It is a compiled language. It is simple, it is readable, and it is based on C. A little history about Go. So Go was initially created by Google. It was announced in 2009, and it was released as a open source language in 2012. And it was created due to a joint dislike of C++, which was surprising to hear.
I didn't realize Go was this old. I thought it was a fairly new language.
Yeah, it's considerably old. Well, it's not old, I guess, but it's established.
Yeah,
We could put it that way. I mean,
yeah.
it's no C, right? But
Huh,
it's getting up there now.
cool.
So why use Go? Well, it is a very fast language. It has fast compilation times. It is very easy to use, especially if you are used to something like C. It's very similar syntactically to something like C. It has a lot of quality of life improvements over a lot of other languages. It is a very high performing language, and it is baked in with useful tools like linters, package installers, things like that. So if anybody wanted to get started with Go, these are the documentations to get started and install it. There's the official documentation with official installation instructions from Google, and then there is also a nice tool called GVM. I like to use GVM because it helps to sort of hot swap through between different versions of Go. Sort of like if anyone's familiar with NVM or JVM, same sort of thing. It just you can switch between versions, test your code with this version, with a different version, and make sure that it's backwards compatible. So we'll get started with a little bit of code here. So Go implements packages through an import statement. And so we'll get right into some code here. Can you guys see my VS Code?
Yep.
Perfect. So up here, you'll notice I've got a package main. So every very similar to Java, you have to have a main.go file, and it has to contain a main function. So it's sort of like Java or C++ or C. You've got to have your main function, and this is where the application runs basically. And this main function has to be a part of the main package. Without a main package, it won't work. And this is how you would declare a package. So if we wanted to declare a different package, we're basically gonna build a little greeting application here. It's not gonna be anything special or anything like that, but let's say, for example, I want to create a package called greet or greeting or something like that. We declare it that way. And when we want to use it, we can import it just like this. and that'll import your package for you.
Okay, that's cool. So it supports like URL imports right out of the box.
Yes. So basically what you need to do is you have to initialize a go.mod file.
Okay.
This is important when it comes to building your Go modules. Otherwise it won't compile.
Right. Okay.
You can specify the version of Go that's required with it. You can specify dependencies as well. So if say you have another application or library that you've built that you want to import into it, and manage versions, which versions you're importing, you can do that as well through the go.mod. The go.mod is basically it's essentially like, you can think of it as like a package.json.
Okay. Yeah.
Anyways, so variables. So there are a lot of different types of variables in Go, just like in any other language. There's two different types of notation for your variables. So you've got your static notation and your dynamic notation. So a static notation is when you declare the type of a variable you want to declare. And a dynamic notation is when the variable you've declared infers the type based on what you're providing it with.
They have both.
So
That's
for
cool.
example, if I want to declare an integer, I can declare an integer called I var I int equals 1. Now you'll notice here that there are some errors. That's because it's not used. Go comes with, like I said, some nice linter, like built-in linter features. So what you'll see when I hit save, the import disappears because I'm not using it.
Right. Okay.
Similarly, if I implement like a, well, maybe if I could spell,
Oh.
if if I implement a package like FMT without importing it first, it'll import it for me.
Oh, nice.
So that just adds for some, like I said, it's one of the nice quality of life things with Go. You do have to set up your VS Code or whatever your IDE is to work with that, but it comes baked in with Go.
Okay. That's nice.
So back to this. So we've got an integer called I, and we've got an integer, we'll call it J. These are two ways, and two very valid ways to declare an integer in Go. So basically, we've declared an integer, and we have inferred an integer.
Is that what the colon equals is for?
Yes. So a colon equals is basically, it's notation for a variable that has that you are initializing for the first time, if you're doing it this way.
Okay.
So if I were to redeclare, like let's say I want to change what J was, I would no longer need that.
Right. Okay.
And you'll see that if I do it, it'll give me an error.
Oh yeah, I see. Is there any sorry, is there, like, do people prefer doing dynamic, or is it kind of like just based on the code base?
I mean, like for example, where I work, it's sort of a wild west when it comes to stuff like that.
Right. Yeah.
Typically, like integers, you can tell it's an integer, depending on how it's used. The problem comes in when you're dealing more with pointers or pointers to structs, but we'll get a little bit more into that later.
Okay.
But yeah, typically with stuff like that, it's easier to just declare it, unless you have a function definition that explicitly returns a pointer to a struct or something like that.
Right. Okay.
Now, so the interesting thing about Go, one of the interesting things, I guess, you'll notice here, there is no double. So we have a float 64 and a float 32. Float 64 is a double. It is their version of a double. It's just a double is basically a 64-bit float. So that's the only difference. They just kept it consistent as opposed to having two different types. And then your usuals, your string, your booleans, Errors are an actual type in Go. And we'll get more into errors later, but what you'll notice is that there is no error throwing or anything like that. Error handling is much different. We have structs. Structs are very similar to what you would find in C. We have slices. Slices are basically just a different take on arrays. They just tend to be faster and more reliable, I guess. The difference between a slice and an array, as far as I understand, is an array cannot be, the size of an array cannot be changed, while a slice can be.
Oh, I see. Okay.
And then you'll see we have a nil. Go doesn't implement nulls. Their version of null is nil. It's the same thing. And then you can actually build your own custom types as well. So structs, what are they? Well, it's basically just a way to structure your data, put simply. So if we declare, let's say we go to our greeting here and we declare a new greet struct. We can call it greeting, and it will contain a name, which is a string, and a message, which is a string. Sure, simple enough. Now, again, what you'll notice when I hit save, it formats it nicely for me. If I were to add some like ridiculously long name to it,
oh, that's nice.
It just lines it all up. It's just for readability. Like I said, another one of those quality of life things. So now we have a greeting struct, so we can utilize that. So we can create a new struct. We'll call it. So here's the catch. We have to call it directly from the package we've just declared.
Oh, okay.
So there is no way around that. There's no way to just like there is. So I'll talk a little bit more about this later, but you can alias imports.
Oh, okay. Yeah.
So if we were to call it just G, we can import it from G.
Okay.
Typically, it's frowned upon unless you have multiple packages that are similarly named. Like let's say you have multiple repository packages. You could call one like a user repository and the other one an account repository or something like that. And so we have a greeting. We've got to give it some information. So we'll call this one Kobe.
Good name.
And we'll go message. We'll say hello. So we have to do something with it. So why don't we just print it out? So let's see what happens.
Yeah, I'm curious.
So you'll notice we print out the entire struct. That's okay. I mean, it's not bad. That's reasonable. But if we dereference it, now it's a little cleaner looking.
So what is this dereference?
So it's basically like when you think about it, greeting here holds a pointer to this new struct we've just declared.
Okay.
Okay. And so it knows how to handle these structs. And so typically, like if I were to say, for example, declare an integer called, I don't know, 1, and then I have P, which is just equal to a reference to I, for example, right? And I print out P. Oh, I didn't save it. Oh, yeah. So, okay, here's the other thing. Compiler errors. Basically, it will not let you have something declared and not use it, which is nice in some ways, bad for stuff like this. So now we print out, it basically just
Okay.
prints out the pointer memory address.
Right.
So now if I were to dereference that, now we get the actual integer, the
Okay.
actual value held in I. So if I were to say, I could increment that value and print I, it should print out 2.
Okay, I see.
Yeah.
Cool.
Yeah. So let's go back. So tags. So tagging structs. So I won't be able to go into a lot of detail. I can show you a little bit about it, but I won't be able to really go into detail. But you can tag structs. Oops, like this. And so one of the nice features of Go, so Go is basically built to be a web language.
Right.
That's sort of one of the main reasons it was built in the first place. It was designed to be a backend programming language, and serve as like a backend server. And so when you bring in a request body from the front end, it's typically formatted in JSON, right? And so basically, what you're telling Go is that when you want to bind your request body to a struct. So if I were to receive a JSON like this, and then like this, I'm basically telling Go, okay, when you receive a JSON object, I want you to bind this JSON property to this name property. And so you can do interesting things with this. So what you could do is you could call this first name, and then it will always look for this JSON property and populate first name with that property.
That's nice. That's really nice.
It makes handling JSON really, really nice.
Yeah, no doubt.
It's the same thing whenever it goes the other way around too. So it's not just requests, but responses as well. When the backend responds, and you want to parse it into JSON, it will always take this field, and it will, when it formats the JSON, it will create a JSON property called name and populate it with the value that's in name, or in this case, first name.
Yeah, that makes so much sense as a like you said, a web first kind of language. That's incredible that it's built in because yeah, imagine how much boilerplate you're saving by this
Yeah.
simple thing.
Yeah. And a lot of like the JSON decoding tools are very, very nice and work really well. And then there are a lot of packages out there like Gin and Gonic, I think, or Echo. I think the one we use is Echo at Coho. It's got a lot of binding tools built in that just use like the marshaling, like the JSON marshaling and unmarshaling for you. But it makes it a lot easier.
That's really slick.
Yeah. Function declarations. So this is one of the most interesting parts about Go. And this is the part that took me a while to wrap my head around. There's two things that took me a while, was the functions, the function definitions, the return types, but then also errors and error handling. So when we want to declare a function, let's say we want to create a new one and we want to call it, let's go with func greet. And maybe it takes it takes a greeting and it returns a string. So we would return and what we would do, we're just going to format a string here. Take greeting dot message and greeting dot name. And so this function here basically just formats a string for us. So it basically takes in your template, your string template, and it can take a whole host of, or a whole list of strings or integers or whatever, and it will fill these templates in for you, resulting in a string. So if we come here and we will have to import that.
I guess the linter probably wouldn't be able to find that kind of thing out for you, hey? Like, you
No,
could just
well, I
automatically-
think it might actually. I don't know if it does. I've never had luck with that, but
Yeah, I guess that'd be kind of a tough one.
yeah. Usually, I think after the first import, sometimes I think it's a VS Code thing. I don't think it's
Oh, okay, yeah.
necessarily like Go's linter. I think it's a VS Code issue. I think if you were to use like Goland, it works a lot better.
Oh yeah,
But that's like designed for Go.
that's fair.
And so we could, let's say, print greeting. We have a greet function and we'll pass in the greeting. So let's see what happens. See if it gives me any. It's giving me errors, but I think it's just, well, let's find out. Oh, of course.
Does Go do like relative imports? Or is it
In what sense? Like
I can, like, for example, this is JavaScript, you could just / greeting. They do that kind of thing in Go, or is it
oh
all?
no, they don't. No,
No, okay, yeah.
no.
Yeah, that's fair.
Maybe I typed this wrong. Yeah, there we go.
Oh, that's case sensitive.
Apparently. So greet is undefined, but I have it. So that's interesting.
Is it because your package is named the same as your variable? Or does that not matter?
Oh, you know what? That could be it. No, that shouldn't be it.
Okay.
You know, let's just call this G just to be safe.
Oh yeah, still scoopy.
Oh, yeah. Yeah. Okay. No, I don't know why. It's because this takes it's because I'm passing in a struct, but I need to pass in a pointer to a struct.
Oh, I see, okay.
And so we get hello
There
Kobe.
you go, yeah. That's very cool.
So receiver functions. So this is interesting. I like receiver functions. So a receiver function is basically a way to tie a function directly to a struct. And so what we could do, so basically every time we call this greet function, we need to pass in a greeting to it.
Mhm.
But instead, what we could do is we can turn it into a receiver function. And basically what this is saying is that every instance that we declare of greet,
Mhm.
or every instance of greeting that we declare, we can call greeting from it. So we'll just get rid of that. We'll call it G. And then in this sense, all we have to do is call greet.
Right, okay.
And there we go.
Can you do multiple? Like, can you go back to the greeting.go?
Yeah.
Can I, like, let's say I had a different class, but I wanted to use this greet function or a different struct, sorry. Could you do the multiple types in there, or is it one receiver?
It's
One
only one
struct?
receiver.
Okay, I see.
So it takes one receiver, but you can return multiple values, which is interesting. This is one of the things that took me a while to wrap my head around. So let's say, for example, so basically here, what we're saying is that we have a greet function
Mhm.
tied to an instance of greeting, and it will return a string and an error. So now you'll see we have a syntax error here. We're not returning enough values. So what we have to do is we have to return a nil in place of the error.
Wow, what a crazy syntax.
So what we can do, and this is where it's really useful and really like one of my favorite parts about Go, it makes it really clean when error handling.
Mhm.
So let's say, for example, I have a, I want to make sure that name is not an empty string. So what I could do is I could create a new error. So I could return, actually I could return, yeah, it would be an empty string. And I can return, I think it's, yeah, new name must, name cannot be blank. So in this case, if name is blank, we return a blank string and a new error with a message. So what we could do is we could call call a message and then an error, and then g.greet.
Okay, that's cool.
And if error is not nil, then we could I can't remember. We could panic or something like that, I suppose. We wouldn't typically panic on something like that, but just for demo purposes. Otherwise,
Oh, we're at a 10-minute warning, by the way.
oh geez, already.
Yeah.
Otherwise, we just print the message. And so we get the message, but if we were to create a blank string, we should just panic.
Okay, that's cool. That is really a clean way of doing it.
Yeah, it's really nice instead of having all the try catch blocks.
Yeah, they're so messy.
I just covered errors. Loops. So let's say, for example, I have, I don't know, a slice of integers, just like that, and I want to loop through them and print them out. We would create, so I equals 0, I is less than length of the nums, I plus plus. We can just print nums at I. And this should just get us, yeah. So the thing about for loops in Go, there are 3 forms. There's this form. We also have a range form. Where we could just cleanly print out each value of the array
Nice.
or the slice. Or we can treat it similarly to a for loop.
Interesting.
So Go doesn't have a for loop or a while loop. For loops are everything in Go, which is nice. You don't have to remember all the different types of loops, I guess, the for loop, the while loop, the do while loop. It does not have a version of a for loop that acts like a do while loop. It is simply just a for loop that has different forms. If else, very, very straightforward, similar to something that you would see in anything else, or any other language. We'll say that's equal to 40, and if I is an even number, else odd. So what you notice is they really don't like their brackets.
Yeah, no doubt.
That's a hard thing to get used to when you're used to brackets. But in my opinion, it just tends to look cleaner. And I've shown you how to compile and run it. There's two different ways. You've got your Go build, very similar to like C syntax. So we could call it program or something like that, and then just run it.
Okay, yeah.
Or you can quickly run it like I've been doing, just like this. But yeah, that's it.
Pretty
That's
cool.
all I've got for you.
Gotta say, I'm pretty impressed with like you say, the developer experience and how clean the syntax is.
Yeah, it is quite nice. I really like writing Go. Actually, it's very easy to pick up and run away with. Like, it's especially if you're used to something like C. It's fairly close, but like I said, a lot cleaner in my opinion.
It's like a lot of the boilerplates taken away for you.
Yeah, yeah. Any other questions or anything?
Do they have classes or just structs?
So it's just structs. So Go is not an object-oriented programming language.
Okay,
It is object-oriented like.
right.
So there are a lot of things that I just not enough time to get into, like interfaces and stuff like that.
Okay, yeah.
But it does support interfaces and all that stuff. A lot of object-oriented type of things, a lot of those principles, but it is not an object-oriented programming language.
Right, okay. Yeah, that's fair. It looks really cool. I am really impressed with the simplicity of it. I mean, obviously this is pretty simple example, but I imagine that even jumping into a deeper code base, it wouldn't be super overwhelming. Because like you say, the error handling is just so nice. I think I mean, it seems like a lot of languages kind of add that at the end with it. Basically just, yeah, try catch everything, it's fine.
Yeah. Yeah, and that's the thing, right? Like something like Java, it's, you have to throw this error if you want to handle the error, and then you have to try and then catch the error, and right, it gets messy. It's a lot of unneeded code, whereas like error handling in Go, it's just it's very easy to see it, right? It's right there. You make a call, you handle the error right there at that call, and then move on.
Yeah, it is really, really clean. I just have one more quick question. Did they have async built in as well?
Yes. So Go is
Okay.
actually it was designed first and foremost to be a web language, or like a backend language, but also to support concurrency. So those are the two things that they built it around. Now concurrency, it takes a little bit more, like a lot more to get into. We really just don't. 3 minutes is nowhere near enough time to get into it, but
Yeah, definitely.
essentially like the syntax for it, so you would essentially create a channel, and then you would call a Go routine, which would utilize that channel to like, you think of it as like a thread.
Right, okay.
Sort of like multi-threading. It's like the syntax is, that is where the syntax is a lot weirder.
Mhm.
But when you want to call a concurrent function or something like that, you just throw the word go in front of it.
Okay, that's kind of funny.
Yeah.
I like that. Okay, cool. Yeah, I kind of assumed that it would be built in because, like you said, it's built for the web, but so is a lot of other things that don't have it. So
Yeah.
that's nice to know. Does anybody else have any questions? We got just over 2 minutes left here. No, I'll take the crickets as my answer. Thank you very much for doing this, Tyler. This was really, really awesome.
Yeah, no
And
problem.
yeah, I'm very excited to dig into more Go. It seems like a really fun experience. So
Yeah, it's a super cool language. I mean, like if anyone wants, like I can do another presentation on actual like back end development with it. Maybe with like more time
yeah, I know
rather than
40
like
minutes is
40
tough.
minutes. But yeah, I could build like a web server on the side and then go into what it's doing and how to do certain things and stuff like that.
Yeah, that'd be really cool. That'd be interesting. Yeah, I think we
Yeah.
would need more time, but